Okay. So, so we're gonna group the first two terms and group the last two terms. Number two, we're going to factor out the GCF from each group. So this is going back to what we just did. Factor out the GCF from each group. Number three, you're going to, once you factor out the GCF, factor out the parentheses. Now, be careful with the parentheses. The parentheses must be identical. The parentheses must be the same. It must be identical. If it's not identical, then something went wrong. All right? So now the next step is to go ahead and write the factored form. I'm going to switch over to another screen. Remember, guys, I am now recording this, so whatever you don't get, I am going to upload it for you. Okay, so here's step number 4. We're going to write the factored form. Now, for the factored form, it's going to be 2 parentheses. So something like this, okay? Once you're done factoring the problem out. Now, I am going to start with an easy example so you guys can see what I'm talking about. I'm starting with number 6. Number 6 is one of the questions from the assignment. Here it is. As you can see, it's got 4 terms. Typically, you know to factor by grouping if your problem has 4 or more terms. If it's got 4 or more terms, it probably means you're going to have to factor by grouping. All right, guys. So for the factoring by grouping, here's what I'm going to do. I'm going to put parentheses around the first 2 terms, parentheses around the last 2 terms. All right. So what I've done is just broken up this problem into 2 groups. So now I am going to factor out the GCF from the first group. Now, the GCF from the first group is the A. That's what they have in common. So I'm going to factor it out. When I factor it out, I'm left with B plus 5. So if I take out the A from here, I'm left with B. If I take it out from here, I'm left with the 5. So now I'm going to go to the second group, and I'm going to factor out the GCF. Anybody know what the GCF is in the second group?
2.
2, very good. So I'm going to factor out the 2, okay? So if I take 2b and I divide it by 2, so 2b divided by 2 leaves me with b. 10 divided by 2 leaves me with 5. Now, what you will notice is that these 2 parentheses, they are identical to each other. So which means we're doing a really good job since the 2 parentheses are identical to each other. So that parentheses becomes another GCF. So we're going to factor it out, b plus 5, okay? And so once we factor it out, from here, that leaves us with an A, which goes inside the second parentheses. Factor it out from here, and that leaves us with a 2 that goes inside the second parentheses. And so this represents the factored form for this particular problem, aka factoring by grouping. All right, guys, so take a moment, look at it, see if you have any questions. 2, I see it. Okay, any questions, guys? What's the attendance code? 6181 is the attendance code. 6181. All right, I am going to do another one with you guys. All right, any questions? Remember, you can ask me the questions or type them in the message box. Hi, Georgia. Hi. Okay, remember you can chat with me in the chat box. To get to the chat box, just go ahead and hover over your screen with your mouse, and at the bottom you'll see what says chat. Just go ahead and click on that, and you should see the chat box appear to your right. Now, furthermore, you can also click on Manage Participant. If you click on Participant, you will see your name. If you need to raise your hand, you can raise your hand and ask a question. But I'm just moving along. And so this is very relaxed. So ask me questions either by speaking to me or typing it in the chat box, okay? Are they added together or multiplying? Which one are you talking about, Paul? Okay, if you're talking about the answer, we are multiplying the answers together. Added together, multiplying the answer, yes, thanks. Okay, so yes, these are being multiplied together. Now, the beautiful thing about this, Paul, is that if you were to multiply these as in FOIL, remember FOIL? If you were to FOIL these, it would take you back to the original problem you started with. So once again, if you were to FOIL these two, it should get you back to the original problem. So basically, when you're factoring, you're undistributing the problem. That's all you're doing. You're doing it in reverse. Before we were foiling to get to this polynomial up here, so now we're doing it in reverse. All right, guys. So I'm going to move on to a second example on factoring by grouping. And so this one right here is going to be number 7. And for number 7, I've got 3xy minus 2x minus 12y and then plus 8. This one is number 7 from homework 5, homework 1, module 5. Module 5, homework 1. That's what I'm working through. All right, everyone. So for the first one here, for number 7, we are going to, once again, factor by grouping. So what I'm going to do is put parentheses around the first two, group the first two, and then group the last two. Now, if you look carefully in the first group, 3xy minus 2x, what do they have in common? What do you guys think? What do they have in common? What do these things right here have in common?
X.
They have an x in common, okay? They both have an x in common. It cannot be 2x because the first one has a 3 and the second one has a 2, so they wouldn't have 2 in common. So since they have x in common, we're going to factor it out. And what we're left over with once we factor it out is 3y minus 2. Remember, guys, all of this is reverse multiplication. So if we were to take the x and multiply it by each of the terms inside the parentheses, it would give us back what we started with. All right, now for the second group right here, you got to be careful, okay? So this right here has a negative in front of the 12, guys. You see that negative in front of the 12? So that's going to affect the 8 as well. So the GCF for the second group is going to be a -4. -4. Now, why did I go with a -4? Because remember, I want to get back to that first parentheses. I want this parentheses to be identical to this one right here. So I'm going to take 12y, -12y, divided by -4. So that's going to give me a positive 3y. And I'm going to take 8 divided by the -4. So that's going to give me a -2. Remember, my goal is to always make sure these two parentheses, when I factor by grouping, these two parentheses are identical. And they are. So once I notice this, I am going to write down that parentheses 3y minus 2. Okay. And so if I remove it from here and I remove it from here, what do I have left over for the other parentheses? I have x minus 4 left over. The x is from here and the negative 4 from there. And there's your factored form. And that's it. Questions? All right, ask me questions. You can either speak into the mic or you can go ahead and type in your question. Remember, I like questions, guys. Ask me your questions. No questions? All right, there's somebody else I need to admit. Hi, Angelica. Okay, everybody. So, would you like a third example of factoring by grouping? Give me a thumbs up or something. Okay, someone just said yes, so I'm gonna do another example. All right, so let me go ahead and go find another one from the assignment, and we'll do another factoring by grouping problem. Now, be careful with those negatives when you're factoring by grouping. They can be very sneaky. All right, guys. So I am going to do number 9 next. And number 9 is AC plus 9A minus 2C minus 18. All right, and this is number 9 from the assignment. Once again, guys, the goal is to get to the end of the term by completing modules 5, 6, 7, 8, and 9. Some of the modules are very short. They don't have too many assignments on them. And so the next test will include modules 5 and 6. And so once we're done with the work, you guys will have access to the test. The test will be very similar to what we do in the classroom. It will be open for you for 90 minutes. You'll have 90 minutes to complete it, and you'll have 1 try at it, okay? Make sure you guys are asking questions if you're not sure what's going on. Now, on this particular example right here, guys, we're gonna go ahead and factor it by grouping. So we're gonna start off by putting parentheses around the first 2 terms and parentheses around the last 2 terms. And there's your groups right there. All right, so anybody know what the GCF is in the first group? What's the GCF in the first group here?
A.
Yep, that one is A. All right, so what do you have left over once you factor out the A? Anybody?
C plus 9.
C plus 9, very good. All right, now this is where you need to be very careful in the second parentheses. Remember, you have to make sure you factor out a GCF so that what's left over inside the parentheses is identical to the first one, okay? So what should the GCF be in the second group, guys?
-2.
-2, very good. So we're gonna factor out a -2. And if you take -2C, you divide it by -2, that leaves you with C. If you take -18, you divide it with -2, that leaves you with +9. And of course, you should notice that the 2 parentheses, they're identical to each other. So since they are identical to each other, you want to write that down. And so we're going to factor it out from this term. So that leaves us with the A for the second parentheses. Factor it out from this term right there. And that leaves us with the -2 for the second parentheses. So there's your factored form. As always, you can check these. How do you check them? You just go ahead and multiply. You can FOIL these and multiply them together, and that will take you back to the original problem. Okay, so how you guys feeling? You're good? All right. So I'm gonna move on to something else unless somebody wants another example. Okay, any questions? No? All right. So then I am going to go ahead and switch over to homework number 2 from module number 5. And let me see here. Hold on a moment. Let me go ahead and get out of this one and move over to homework number 2. And we're going to be factoring trinomials. Ooh, I'm having a problem here. My internet is slowing down, guys. Okay, let me try this one more time. By the way, if you didn't check in for attendance, the attendance code is 6181, 6181. Please check in for me. And this is being recorded. Okay, I'm still having technical difficulty here. Huh. All right, let me try this one more time. Don't you just love technology? Oh boy. All right, so let me go ahead and at least give you some steps on factoring these trinomials. As I wait for this thing to catch up, I'm just gonna go ahead and go to another whiteboard screen. Okay, so now we are factoring trinomials. Factoring, easy. And there's a reason why I call them easy, okay? I'll tell you in a minute. Trinomials. Now, there's an I in there somewhere, guys, okay? When it comes to factoring the easy trinomials, they all look something like this. X squared plus bx, which would be, plus c. And so when you have an easy trinomial, guys, what you will notice is that the x squared term doesn't necessarily have a coefficient in front of it, although the coefficient is understood to be 1. So because the coefficient is 1, that makes it an easy trinomial. So here are the steps to factoring an easy trinomial. Number 1, set up 2 parentheses. Now, number 2, you're going to factor x squared into x times x. And then you're going to place a factor in each parentheses. Now, here's the critical step. The critical step is number 3. You got to find 2 factors of C whose sum is B. So let me recap this for you guys. You got to find basically 2 numbers that multiply to give you C, and then when you add them together, you get B. So they multiply to give you C, and then when you add them, they give you B, okay? So once again, you multiply to get C and add to give you B. What's that after x squared? Into. All right. So guys, let me go ahead and show you some easy problems, okay? So I can show you what to do with these easy trinomials. I am going to erase the screen right here so I can go to a new one. I'm using my tablet, by the way, so that's why the real estate is so slim. All right, so here comes the first example, guys. Let's say we have x squared plus 9x plus 18. That's an easy trinomial. We're gonna factor this into 2 binomials. So we set up our 2 parentheses. Now, we're going to take the x squared term and we're going to split it up into x times x. You place an x in each parenthesis. Next, we're going to look at the number 18, 18. And for the 18, what we're looking for are two numbers that multiply to give us 18. They have to multiply to give us 18, and then add to give us 9. So what are those two numbers?
6 and 3.
6 and 3. So what we do is we place a factor or one of these numbers in each of the parentheses. So pretty much the factored form for x squared plus 9x plus 18 is x plus 3 times x plus 6. And that's it, guys. This is why we call this an easy trinomial. It's very easy for you to eyeball this and figure out the answers for these. Okay, it's easy for you to find two numbers that multiply to give you 18, and then they add to give you 9. Multiply to give you 18, add to give you 9. Any questions? Okay, now, all right, so let's do another one, guys. So for the next one, number 2, I am going to do x squared minus 6x plus 8. Now, once again, you want to go ahead and set up your two parentheses. And then we're going to go ahead and split up x squared right there. We're going to split up the x squared into x times x. Now, you need to be careful with this one because 8 is positive and 6 is negative. So you got to find two numbers that multiply to give you positive 8 and add to give you a negative 6. So therefore, both factors must be a negative because when you multiply two negatives together, you get a positive. And when you add them together, you get a negative. So what are those two numbers that multiply to give you 8? To give you 8, but when you add them together, you get 6, guys. What are those two numbers?
Negative 4, negative 2.
Right, negative 4 and negative 2. So this would reflect your factors, x minus 4, x minus 2. And once again, you can always check your answers. How do you check your answers? You just go ahead and FOIL. So if we were to FOIL this, we do x times x squared. X times negative 2, negative 2x, negative 2 times x, negative 4x, negative 4 times negative 2, negative 8. And when you add these two together, it takes you right back to the original problem you started with. Look at that, guys. Same thing. Oops, that's a positive right there, not a negative. You see that? Same thing. Okay, so that's factoring the easy trinomials. Now, let me do a couple more, and then you guys will have to let me know if you want me to do some additional examples. All right, so here's the third example. Now, for the third example, I've got x squared minus 9x, and then minus 36. Okay, now guys, this one is challenging. Why is it challenging? Because of those negatives in there. Okay, you have a negative here, and you have a negative with the 9. Okay, so for this one right here, let me give you a nice little hint. Besides the fact that you need to factor x squared into x times x, well, for the 36, since it's negative, that means that one factor will be a positive, one factor will be a negative. Now, the big question from students is always, how do I know which one is negative? How do I know which one is positive? Well, whichever one is the larger factor will take the sign of the middle term. Larger factor gets sign of the middle term. That's how you know which one is negative and which one is positive. So the larger factor will take on the sign of the middle term. All right, guys. Does it matter the order you put the numbers in the parentheses? In this one, it matters. But in the previous two, it doesn't matter. This one does matter because you want to make sure the larger factor gets the sign of the middle term, okay? So guys, let's do this one. So on this particular one, we got to figure out two numbers that multiply to give us 36. Think about numbers that multiply to give us 36. We have 9 and 4. We have 12 times 3. What else do we have? 18 times 2. Okay. Now, we want the 2 such that when we multiply them together, we get 36. But when we subtract, we get a 9. We get 9. So 9 times 4 is 36. But when you do 9 minus 4, that does not give you 9. That doesn't work. Okay, so let's try the second one. 12 times 3 is 36. And 12 minus 3, that does give you 9. So this is the combination that's going to work. And so since the factors are 12 and 3, which one's the larger one? The 12 is larger. So the 12 would be negative and the 2 would be positive. So in this instance, it does matter which one is negative and which one is positive. And so this would reflect your answer. All right, guys, ask me some questions, anything. You can type in your questions or you can ask me directly.
Did you mean
We're
to
good?
write E in the parentheses?
Relatively easy, I think somebody said.
No,
Right.
did you mean to write
So
a 3?
give me a thumbs up if you're good with this. All right, I'm not seeing any thumbs. Oh, one thumbs up. That's it? Okay, so that means that you guys need to practice some more. Do you mean to write a 3? Oh, Shazam, you're right. You're absolutely right. Good catch, man. Good catch. All right. All right. So let me go ahead and fix that in there. Very good. Excellent. All right. Anybody else? All right. So thanks. That was good. Good catch. All right, guys. So I'm going to do another example with those negatives in there. So I'm going to go ahead and start this new whiteboard. So here we go. This one right here is going to be x squared plus 5x. Oh, you know what? Let's just do minus 36 again. All right, guys. So here it is. We set up the x squared into x times x. And of course, because the 36 is negative, we're going to have a positive factor, a negative factor. All right, guys. So once again, here's how I approach this. I want two numbers that multiply to give me negative 36, and they add to give me 5. Or you could say two numbers that multiply to give you positive 36 and subtract to give you a 5. I think the second option is better when it comes to dealing with the negatives. So think about it, guys. What are two numbers that multiply to give you 36? And then when you subtract them, okay, you get positive 5. What are they?
Positive 9 and negative 4.
Very good. Positive 9 and negative 4. So on this one right here, guys, the 9 will be a positive value, and then of course the 4 will be a negative. So if you were to take 9, you multiply it by negative 4, you get negative 36. And if you take 9, you subtract the 4, that will give you a positive 5. So there's your factors. And that was the fourth example. All right. Now, one of the features on here, guys, allows you to annotate, as in write on my screen. So it's going to be your turn for you to write the answer on the screen. You can type it or you can write it. So let me go ahead and give you an example problem, and you give it a try. Okay, this one is going to be x squared plus 8x. Let me see here. Okay, we'll do minus 20. You guys give this one a try. All right, you can write it on my screen so I can see your answers. I want to know who it's coming from. How do we do that? You said right on your screen. Okay, if you go to the top of the screen, you will see where it says you are viewing Elcira's screen. Click next to it under options. It'll say annotate. And if you select the annotate, you can actually write on my screen. Ooh, you guys haven't figured it out? Ooh. Anybody? You can also type it in the chat box too. That works too. Oh, there's one person. All right. Okay, x plus 10. X minus 2. Very good. Awesome. All right, whoever that was, good job. Very good. Okay, so yes, guys, this is the correct answer. You want to find two numbers that multiply to give you 20. When you subtract them, you get positive 8. Yes, 10 times 2 gives you 20. All right. And then 10 minus 2 gives you 8. So another way of saying this is that 10 times negative 2 gives you negative 20. All right. And when you subtract the 10 and the 2, that gives you the positive 8, which is the middle term. Good job. Good job. All right. So do you guys want another one? Give me a thumbs up if you want another one. Any way to solve this, please. Let me see. Asha, I am trying to access the assignment right now, and it is not letting me. Any way to solve this? Okay, I cannot do it on my own, on my side over here. It seems like the system is having issues. Let me see if I can go in and access one of my assignments. Remember earlier, I was telling you guys how I was trying to access an assignment and I could not get into the assignment. I'm trying it again. It's still giving me issues. So which means my math lab is probably down, guys. My math lab is down, so it's not working at the present moment. All right, so they're having technical issues. So just give it a little bit of time before we try it again. So in the meantime, if you would like an additional example, give me a thumbs up if you want another example with the easy trinomials. If you don't, I will go ahead and move on to the hard trinomials. Anybody want an example? No? Oh, okay, so you guys got this. All right, perfect. So then let me go ahead and move on to the hard trinomials. And guys, remember, you can ask me your questions by typing it into the box. You can raise your hand. I should be able to see it. Okay, so now moving on to the hard trinomials, guys. And the hard trinomials are challenging. All right. I have a crack on my screen, so that's why there's so much space right there in between. So we're looking at the hard trinomials now. For the hard trinomials, we're looking at problems that look like this, the trinomials that look like ax squared plus bx plus c. Now, what do you notice about this one in relation to the previous one? There's an a value. As in the leading coefficient, the number in front of x squared is no longer 1. It's going to be more than 1, greater than 1. So when we factor the hard trinomials, guys, it's going to be a bit more challenging. Now, one of the methods we use to factor the hard trinomials is called the AC method, as in A times C method. As in the product of A and C. You're going to have to multiply A and C together. So here's how the AC method works. Number one, you want to multiply A and C. You're going to find the product. Find the product. Product means multiplication of A and C. Find the product of A and C. Now, step number two, you're going to find two factors of AC whose sum, and I'm going to clarify this for you, is B. All right, guys. So this is really important. So step number two is to go ahead and find two numbers, two factors of the AC. And then those two factors, their sum has to add up to B. What B am I talking about? The B from the original problem. So once again, guys, we are looking for two factors that multiply to give us B. And then, they multiply to give us AC. And then when we add them together, we get B. Now, once you figure out those two factors, step number three is to go ahead, and this is going to be a little confusing, but I'll clarify it for you once I start doing the examples, okay? Step number three is to go ahead and rewrite the trinomial by splitting. We're going to split the middle term. I know this is a little confusing, but I will clarify it for you in a minute. Now, once you have that middle term split up into two terms, the sum of two terms, what's going to happen is you're going to have a four-term polynomial, and to factor the four-term polynomial, we're going to factor it, here we go again, by grouping. Factor by grouping. All right, so I'm going to pause on here so you guys can finish writing, and then I will go ahead and start looking at some examples with you guys, okay? I'm going to have to go to the textbook and get some examples. All right, how you guys doing? Thumbs up? No? Okay. All right, guys, I'm about to erase it so I can go ahead and get started on some examples. Okay, we're good? All right, so here comes the examples. All right, I'm gonna make this one easy. It's 2x squared, let me see here, plus 11x plus 5, okay? 2x squared plus 11x plus 5. All right, guys, so here's the process. We're gonna take the 2 and the 5, and we're gonna multiply them together. So 2 times 5, that's 10. And then we gotta find two numbers that multiply to give us 10. And when we add them, we get 11. They have to multiply to give us 10. And then when we add them, we get the middle term, 11. What would those two numbers be?
1 and 10.
1 and 10. So 10 times 1 would be those two numbers. So here's that third step that was a bit confusing. So now we're going to take the same trinomial. We're going to rewrite it as by splitting up the middle term right here. We're going to split up 11x into 10x plus 1x. That's that third step I was talking about, guys. Rewrite the trinomial by splitting up the middle term. So once again, I am splitting up the middle term, 11x into 10x plus 1x. That's still 11x, but the difference is it has been split. And so now we have a 4-term polynomial. And how do we factor a 4-term polynomial? By grouping. So we're going to go to the third step and factor by grouping. So we're going to group the first 2 terms, and we're going to group the last 2 terms. So group the first 2, group the last 2. Okay. So in the first group, guys, we have a GCF of 2x, which we're going to factor out. So here, if I were to take the 2x squared divided by 2x, that leaves me with x. If I take 10x divided by 2x, that leaves me with 5. Now, here's another tricky step about this problem. For the second group, guys, we got x plus 5. We need a GCF that's not going to change the x plus 5. So what should the GCF be so it doesn't change, it doesn't alter the x plus 5?
1.
Yep, that's going to be a 1. So we're going to factor out a 1, and that leaves us with x plus 5. Now, of course, because we're factoring by grouping, the 2 parentheses must be identical, and they are. Notice x plus 5 is the same thing as x plus 5. So we factor that out. And when we factor it from here, that leaves us with 2x for the other parentheses. When we factor it out from here, that leaves us with 1 for the other parentheses. And so, guys, this is the factored form of this hard trinomial. And as always, you can check your answer. How do you check your answer? You go ahead and FOIL out the 2 binomials to see if you get back to the problem you started with. Any questions? Okay, now this is hard. They call them hard trinomials, guys, for a reason. So obviously these are hard. So let's go ahead and practice a little bit more. By the way, this goes along with module 5, homework number 3. Module 5, homework number 3, okay? So I'm gonna go on to a second example, if you guys are ready. You guys are good? All right, so here comes the third example. Now, for this one right here, okay, it says I have reached my maximum on the whiteboard screen. Now, how do I add some more? Okay, let me save these. Okay, perfect. All right. So hold on a second, guys. I'm saving the first few slides, and then I am going to go ahead and start a new one. Oh, it's not allowing me to start a new one. Okay. Hold on a minute. Okay, you know what? I am going to, let me go ahead and get out of this share right here and start a new one. Okay, hold on a second, guys. So, okay, I'm having a little technical difficulty myself. Hold on a second. Let's see. How do we add more on here? Okay, clear all drawings. We did. Okay, guys. So let's see here. Here's the next one, number 2. It is 4x squared minus 8x. This is not working out. Okay, let's try it one more time. 4x squared minus 8x plus 3. There you go. Okay, let's try this one out. So for this one right here, guys, the A value is 4 and the C value is 3. We're going to multiply them together. So 4 times 3 is going to be 12. And then we want to find two numbers that multiply to give us 12. And of course, when we add them together, we get 8. They got to multiply to give us 12. And when we add them, we get 8. So what are those two numbers, guys? Anybody?
4 and 2.
Say that for me one more time. I didn't hear you. Oh, I heard it. Okay. 6 and 2. Somebody just typed it in there. Very good. So I'm going to take this and rewrite it as negative 2x minus 6x plus 3. Once again, guys, okay, let me go ahead and mention this. Here, the order doesn't matter. You could have done negative 6x minus 2x, or you could do the negative 2x minus 6x. It doesn't matter in which sequence we write this. Now, once we're done with this, we have a 4-term polynomial. We got 1, 2, 3, 4 terms. So now we're going to go ahead and factor it by grouping. So we're going to put parentheses around the first 2 terms and parentheses around the last 2 terms. And now we're going to go ahead and factor by grouping. In the first group, they have a 2x in common. So we're going to divide each term by 2x. And when we divide each term by 2x, what do we have left over? For the first term, we have 2x. And for the second term, if you take 2x divided by 2x, that should give you a negative 1. Now, any questions? Remember, you guys can ask your questions or type your questions into the chat box. All right, guys, so your turn. Here's your question. What is the GCF for the second group? Anybody?
Negative 3.
Negative 3, very good. So we're gonna factor out the negative 3. And so remember to figure out what's left over inside the parentheses. You wanna divide each term by negative 3. Each term by negative 3. And negative 6 divided by negative 3 leaves you with positive 2x. And of course, 3 divided by negative 3 leaves you with negative 1. And as always, guys, when you factor by grouping, you have to make sure that these two parentheses right here are identical to each other. And they are. So since they are, we're going to go ahead and factor out the 2x minus 1. Factor it out. And then once you factor it out from here, that leaves you with 2x. And then factor it out from here, and that leaves you with negative 3. And there you go. All right, guys. So that was the second example for factoring out the hard trinomials. Any questions? All right. So I think I'm going to give you guys one to try on your own to see how you feel about it. You ready? Okay, so I'm going to erase this. Let me give you an example. All right, so here it comes. This is going to be the third example. It is 4x squared minus 20x. That's an x right there, guys. It's not coming out because of that little problem I have with my tablet here. Plus 25. That's an x right there, okay? So you guys go ahead and give this one a try. Let's see what you come up with. And let me go ahead and try my math lab and see what's going on while you guys are trying the problem. Let's see if it's responding here. Okay. Nope, I'm still having issues. Asha, can you go ahead and give it a try on your end and see if it's working for you now?
Yeah, I did, but it's still not working.
Okay. So then that
So
means
sorry. I have like one assignment left to do. So if it does not, load up by tonight, what is gonna happen to that assignment?
okay. It could be that there's a large number of individuals trying to access the assignments right now, and that's why it's not working.
Okay.
So just give them a little bit of time. It hasn't been working for me all week. I worked on it, Shakira. I worked on it today, actually. I went in and changed the deadline on the assignments. I was looking at Module 5, homework number 1. It was working for me earlier. It just started not working. This is around the time class starts. So if you have many students trying to access the system at this time, then that means that it's going to slow down. So I think that's what's going on. All right. So how you guys doing with the problem? I tried on Safari and Google Chrome, but I'll try again. All right. Remember, right now it's having issues, okay? So whether it was working earlier or it wasn't working earlier, right now it's definitely not working, okay? So how you guys doing with the problem? Anybody have the answer and want to type it up on the screen?
That's cool.
Nobody wants to give it a try? Remember, you can annotate on here, guys. You can go ahead and type it in. All right, how are you doing? Okay, let's work on it together then, all right? So on this one, guys, I am going to multiply A and C together. This is the, oh, somebody's typing, okay. All right, 2x minus 5. Isn't it difficult to write on there?
I'm struggling, but that's a 2. That's 2 minus 5.
You can type it in. You can do a text box and just type it in there. It's really hard. So for me, I'm using my iPad. I'm writing on my iPad. That's why it's easier for me. Okay, so I'm saying 2x minus 5. Is the other one also 2x minus 5?
Dang.
No, it's just 2 minus 5.
Okay, 2 minus 5. Well, you almost got it, except that 2 in the second parentheses should have been followed by an x. So you should have had an x over here. Let me change the color, okay? So you should have had an x like right there.
Oh,
right?
yeah, I do have 2x. Sorry.
Okay. So then you're good. That's really good. All right, so let me go over it for those of you who didn't quite get this one, all right? So for this one, guys, again, this is your A value right there. The 4 is your A value, that's A. The 25 is your C value. So we're gonna do 4 times 25. And that's gonna give us 100. Okay, so now the big question is, what two numbers multiply to give us 100? And then add to give us 20. So what two numbers multiply to give us 100 and add to give us 20? And notice, guys, the 20 is negative. So keep that in mind. Both factors are going to be a negative. So for this one, the two numbers that multiply to give you 100 and add to give you 20 are 10 and 10, both of which are going to be a negative. So when we rewrite the trinomial, we're going to rewrite it as negative 10x minus 10x plus 25. And so now you have your 4-term polynomial, and then you can proceed to factoring it by grouping. So I'm going to group the first 2 terms, and I'm going to group the last 2 terms. So here in the first group, the GCF is what, guys? What's the GCF in the first group? Anybody? 2x. Okay, very good. 2x. So once we figure out the GCF, we're going to divide each term by the GCF, 2x. So 4x squared divided by 2x leaves us with 2x. And then 10x divided by 2x leaves us with 5x. I mean, just 5, I'm sorry, minus 5. Now, for the second group, guys, be careful. Look at the second group right there. You have a negative 10x and a positive 5. What's the GCF on that one?
5.
5, not just, okay, I see somebody typing negative 5. Negative 5 would be a better option because if you divide each term by negative 5, it will ensure you get the exact same parentheses as the first one. You want to make sure whatever GCF you select, it has to be a number that is going to ensure you get the exact same parentheses right there, guys, as the first one, okay? So if we take negative 10x divided by negative 5, that leaves us with a positive 2x, okay? And then if we take the positive 25 divided by negative 5, positive 25 divided by negative 5 leaves us with a negative 5. Now, you will notice this parentheses is identical to the first one. So that becomes another GCF, which we factor out. And if we factor it out from here, that leaves us with negative 2 for the second parentheses. I mean, that's positive 2x. I'm sorry, I said negative 2. And if we factor it out from here, that leaves us with a negative 5 for the second parentheses. Now, what do you guys notice about the factors? Anybody notice anything interesting?
They're the same?
They're exactly the same. And so because they are identical to each other, they're exactly the same, we can use exponents to rewrite this as a single parentheses raised to the second power. Single parentheses raised to the second power. So let me go ahead and write this down for you guys so you can see what I'm talking about. Okay, so the parentheses is going to be 2x minus 5 raised to the second power. And that is perfectly acceptable. I hope you guys can see this because mine is kind of cut off. Can you guys see it? All right, good, good, good. Thank you. So guys, that was the third example. So how are we feeling? Any questions? Yes, you can type it in as a binomial squared. raised to the second power. Any questions? All right, give me a thumbs up if you're okay with this. Now, notice I didn't say you totally got it. If you're okay with it, give me a thumbs up. I'm okay with it, thumbs up. All right, okay, I'm seeing a few thumbs up. Okay, Ashley, how you doing? All right, James, how about you? Sebastian, you okay? All right, good. Anybody else? No, so. James is so. James, would you like me to do an additional example? Okay, one more. Absolutely. All right. So let me go ahead and track another example down since I don't have my book here. It's a bit harder for me to come up with the examples. I'm making these up as I go along, guys. Can't you tell? So let me go ahead and clear this one. And let's see here. Okay, all right. So let's see how we do with this one right here. This is example number 4. It is going to be 2x squared plus 12x and then minus 36, everybody. 2x squared plus 12x minus 36. All right, guys. So this one is even more challenging. Why? Because we have a negative there. Now, the way I deal with these problems is this, guys. What I tell students all the time is, if you can do a basic one, and what I mean by a basic one is if that negative 36 was a positive and you can do it, I'm fine with that. You're good. You're good to go. Yeah. All right. Oh, I put 36, Shazam. I'm at 18, guys. Can you change that 36 to 18 for me, please? I'm going ahead of myself here. Okay. So do that for me and change it. Okay, you guys are good? Okay, I hope this works out because I made it up. All right, guys, so here we go. 2 times 18 is going to be 36. Remember, we're multiplying the A, that's the A, and the C together, okay? Now, be careful on this one. We're going to find 2 numbers that multiply to give us 36, and when we subtract them, we get 12. Ooh, I hope this worked. I might have to adjust this a little bit. Okay, we want them to multiply to give us 36. And when we subtract them together, we get 12. Okay, think about numbers that multiply to give us 36. We got 18 times 2. Then we've got 12 times 3. And we also have 9 times 4. Oh, guys, I'm looking at this. I'm not sure it's going to work out. Okay, these numbers are bogus. That's not going to work out. Okay, so let's change a little something here to make sure it works out. I'm going to erase this 12 right here, and I'm going to change it to positive 9. Okay, change that for me, guys, so we can make sure it works out. Okay, change that for me, please. All right, so once again, let's do it again. So we're doing the A value times the C value, which is going to be 36. So 2 times 18 is 36. So now we want to find 2 numbers that multiply to give us 36. And when we subtract them, we get 9. All right, so which pair of numbers works, guys?
12 and 3.
12 and 3. All right. Very good. Oh, nice. I like that. I like how you circled that. Very good. Okay. So now I am going to go ahead and take the trinomial and I'm going to rewrite it, 2x squared. And then when I get to the 9x, I don't write it as 9x. I rewrite it as 12x minus 3x. And what I'm doing here is splitting up the 9x to reflect 12x minus 3x, which is still 9x, and then minus 18. Now, guys, we have a 4-term polynomial. So we got 1, 2, 3, 4 terms. So now we're going to factor it by grouping. So I'm going to go ahead and put parentheses around the first 2 terms, parentheses around the last 2 terms, and now we factor by grouping. So, James, what's the GCF in the first group? All right. Now, do you notice how you have a 2 here and a 12 here? What are the 2 and the 12 divisible by? So yes, they're both divisible by 2. So this means not only do they have an x in common, but they also have a 2 in common. So this means the GCF is going to be 2x. So once we figure out the GCF, you're going to divide each term by 2x. Each term by 2x to figure out what's left over inside the parentheses. So now we're going to take 2x squared divided by 2x. 2x squared divided by 2x leaves us with x. Then we're going to take the 12x divided by 2x. So we get positive 6. Now, we're going to go to the second group. The second group, what do they have in common right here, guys? Negative 3x minus 18. What do they have in common? Anybody?
Negative 3.
Negative 3. So we're going to factor out that negative 3. And that's going to leave us with x plus 6. Now, how do we get that x plus 6? We figured out the GCF was negative 3. So we divide each term over here by negative 3. So when you do your division, negative 3 divided by negative 3, positive x. Negative 18 divided by negative 3, that's a positive 6. Now, what you will notice is that these 2 parentheses over here, they're identical to each other. And since they are identical to each other, you want to write it down. That's the same thing as saying, I'm going to factor it out because it becomes a GCF. Write it down. Eliminate it from here. Eliminate it from here. And what you have left over are the 2 and the negative 3. So those 2 will go inside another set of parentheses. And there you go. There's your factors. All right, guys. So that was a solid example right there. That was a really, really good example. I'm seeing the thumbs up, James. Very good. So I'm happy about that. So pretty much, guys, that's the factoring of the hard trinomials. You got easy ones, you got hard ones. So the AC method will factor every hard trinomial for you. If you're having a hard time with factoring the hard ones, use the AC method. It works really well. All right, so I think I'm going to go ahead and move on to the next part of this. And so for the next part of this, guys, don't forget, by the way, you guys have the quizzes you got to do. You got to do the homework assignments. I pushed back the deadline is the 13th of April for the end of these assignments. If you have assignments in the past that you never worked on, make sure you go back and work on the assignments, guys. Now, I am here for you. If you have any questions, send me an email. You can go ahead and go on Blackboard, or you can send me a direct email, and I will respond to you as soon as possible. Most of the time, I'm in front of the computer now, since I'm just working at home. So as soon as you send me that email, especially when it's during the day, I can just go ahead and respond to you. Okay, Austin, what is all due by the 13th? Module 5 and Module 6. Are we having a final, Sarah? Yes, we are having a final. Now, the final is going to also be administered online. Our last day is going to be on the 27th, guys. Monday the 27th is when we're going to take that final exam. The time is going to be restricted to 90 minutes. I think the questions are all multiple choice, 30 multiple choice questions. Don't quote me on it. It briefly came across my screen. I did not go into the test to look at it and see exactly how it looks, but I will definitely get back to you on that. Let me see, Sarah, are we, okay, no, I just answered your question. Nicholas, it's just you till module 6 right up till, let me see, okay, I'm not quite sure I got your question, Nicholas.
I meant to say up till.
Okay, well, for the next test, we're doing module 5 and module 6 for the next test. And then we're also trying to get to a 4th test if we have time. If we don't have time, what I will tell you is this. I will teach you modules 7, 8, and 9. And I think number 8 and 9 are very short. They're very, very brief, okay? And I will not give you a 4th test, but there is definitely a final exam, all right? When is the next test, Rhiannon? Rhiannon, the next test, I am going to open it up for you guys. Let me see here. You'll have until the 13th to do it. I will unlock it, and once it's unlocked, you will have access to it until the 13th to go ahead and work on it. Now, my biggest concern are those free response questions, because normally I collect your work to see if you get a question wrong, if I can give you partial credit. But you know what I'm thinking, and you guys can give me a thumbs up if you agree with me. Since you're going to be doing this test at home, I'm guessing you probably won't need me to check your work for partial credit. What do you think? No? Nobody's saying anything. All right. So worst case scenario, guys, listen, I will go on and I will check those questions that you get wrong. If you are very close to the answer, I will find a way to give you some partial credit, okay? As always, my goal is to make sure you guys pass this course. I will work with you, and I need you guys to work with me as well so I can help you to pass the course. But the other thing I forgot to mention is that I think there was a couple of you who missed the last test. If you're one of those people who missed the last test, please send me an email so we can make arrangements for you to take the previous test, test number 2, okay? I see what you mean there, but is there any way I can scan my work and send it to you by email? By all means, you can. The other thing you can also do is to take a picture with your cell phone and send it to me from your cell phone. Yeah, absolutely. You can do that. You guys heard that? Okay, so if you're not sure, let's say, you know, you do your work and you submit your test and you end up getting like a really horrible grade, but you know you were doing the correct work, just go ahead, snap a picture of your work, upload it to me, or scan it if you have the ability to scan it and send it to me. I just want to make sure I'm getting the answers using the proper formulas. Yeah, I understand. I completely understand, Shakira. Okay, but I will continue working with you guys. We're all in this together, guys. This is completely unexpected. It's out of our control. We're going into uncharted territory. We didn't expect for this to happen. So work with me and I will also work with you. But again, my goal is to help you pass the course. And I'm sure if you guys stick with me, you will pass the class. Just make sure you do the work though. You got to do the work, okay? Thanks for saying that, Sarah. Yes, do the work, guys. You got to do the work. Do the work, okay? We have a deadline. All right. So I think I'm going to move on to the next part of this. And we're going to, I think it's module 4 now. I mean, homework number 4, module 5, homework number 4. Let me double check. And let me see if we can get into the assignments now. This thing might be down for good. Let's see. I'm going to try it one more time, guys. I'm trying my math lab one more time to see if it lets me in. No, it's still not working. It's still not working. All right, guys. So I am going to go ahead and move on to module 5. Ooh, let me check my time here. Okay, we're good. So I'm going to move on to module 5, homework 4, and then I will do module 5. Oh no, that's going to take us into module 6. So I will do module 6, homework number 1, if we have enough time. If we don't have enough time, then I'm probably going to end at 8:30 with module number 5, homework number 4. And then next week, we'll go ahead and do module 6. By the way, module 6 has a total of 3 homework assignments and 1 quiz. So these are very short sections, basically. All right, everybody. So I am going to get started with module 5, homework number 4. So let me go ahead and clear my board here and get started with this one. By the way, this is all being recorded. So I will upload the video for you guys later on. If you missed something, you can always go back and check the recording. Okay. So module 5, homework number 4. We're looking at special factoring. Okay, special types. That's what I'm going to call it. Special types of factoring. Now, for the special types, I like breaking them down into parts, starting with the easiest one out of all of them, and that is the difference of squares. Now, for the difference of squares, guys, they are in the form of a squared minus b squared. Now, for these, they are very easy to factor. Now, when we talk about a difference, we're looking at that subtraction sign. Okay, so that's the difference. Now, the a squared is a perfect square. Why, or how do we know it's a perfect square? When we take the square root of it, we get an exact value. That's why we call it a perfect square. And the b squared is also a perfect square. Now, let me show you an example. Okay, I'm trying to write an R here, guys. The R is not coming up. That's not a spelling error, okay? It's just not coming out on my tablet here. Okay, so here's an example of a difference of squares problem. X squared minus 36. X squared is a perfect square. 36 is also a perfect square. How do I know 36 is a perfect square? Well, when I take the square root of 36, I get 6. So it is a perfect square. So when you're factoring these guys, you set up 2 parentheses. I'm not giving you steps because these are easy. And then 1 parentheses will be a sum. And then the other one will be a difference. And this is going to be the format all the time, as long as you have a difference of squares. You have to make sure you have the minus sign in the middle. If you don't have the minus sign in the middle, then it's not considered a difference of squares. All right, guys. So here's how we factor this. We factor the first term, x squared. Now, x squared, everybody knows, splits up into x times x. So you place an x in each parentheses, just like before. Okay, now earlier I told you 36 was a perfect square, so you take the square root of 36. Square root of 36 is 6. So you put a 6 in each parentheses, and just like that, guys, you have factored form. x plus 6, x minus 6 is the factored form for this problem. Now, if you guys look carefully, you will notice that these two binomials, they're almost identical except the signs are different. So you guys remember what they're called? When two binomials look
Conjugates.
almost identical except the signs are different, what are they called?
Conjugates.
Conjugates?
Very good. Okay, let me write this down for you guys somewhere here. These are conjugates. So when you factor a difference of squares, you end up with two binomials, okay? So the difference of squares are very easy to factor. Now, for some reason, guys, I still cannot access the problems from the assignment, but I'm gonna try my best to do as many examples as I can to reflect what you're going to see on the assignment. So I'm gonna clear this out and we're gonna go ahead and start with some examples. Number 1, x squared minus 100. Once again, you set up your two parentheses. One will be a sum and one will be a difference. Now, obviously, x squared factors into x times x. And then you want to take the square root of 100, and the square root of 100 is going to be 10. So that 10 will go inside each parentheses. And just like that, guys, you're done factoring this, okay? So this one right here, the difference of squares, they're pretty easy to factor. All right, so here comes another one. And for this one right here, I'm gonna do 4x squared minus 1. Now, again, set up your two parentheses. You have to ask yourself, is 4x squared a perfect square? Can I take the square root of 4 and get an exact number for it? Yes. Can I take the square root of 1 and get an exact value for it? Yes. And do I have my minus sign in the middle? Yes, I have the minus sign in the middle. So yes, this is a difference of two squares. So now, guys, I am going to factor this. Remember, one factor will be a sum, the other one will be a difference. So the 4x squared, we're gonna go ahead and take the square root of it. The square root of 4x squared. Does anybody remember what that is for the square root of 4x squared?
2x?
Yes, very good, 2x. So each parentheses will get a 2x. And of course, you wanna take the square root of 1. What is the square root of 1?
1.
1. Very good. Awesome. So guys, there's your factors. 2x minus 1, 2x plus 1. Very good. All right. By the way, guys, we are no longer doing module 10. I'm guessing that's what your question was, Shakira. Okay, we're not going to be doing module 10, so don't worry about the assignments in module 10. If you're working ahead, you can work up to module 9 and we'll be done. Oh, you were giving me the answer. Okay, all right, thank you. All right, everybody. So here comes another one, number 3. This time I'm gonna do a long one. It's x to the 4 minus, let's do minus 16. Now this one is challenging, okay? Now for this one right here, you will notice we no longer have x squared, we actually have an x to the 4th. So when we split this up, guys, into two binomials, be careful that x to the 4th is going to split up into x squared times x squared. All right, and of course, one of them will be a sum, one of them will be a difference. You want to take the square root of 16, and the square root of 16 is 4. So each parentheses will get a 4. So now you should have x squared plus 4 and x squared minus 4. You guys notice anything interesting about these two binomials?
They can be factored more.
Yes. Can both of them be factored further, or is it just one?
Just one?
Yes, one of them. Now, the only one that can be factored further is the x squared minus 4. Why? Because this is a difference of 2 squared. However, the other one is a sum. Because it's a sum, we disregard it. We cannot factor it further. When you have a sum of 2 squares, we say that it is prime. We cannot factor it. If it's the sum of 2 squared, it is prime because it's not factorable. By the way, guys, whenever you have a polynomial that is not factorable, we refer to it as being prime. Any questions? All right, I'm not done, but I'm gonna have to erase the screen to go to the next part of the problem, okay, guys? So I'm gonna clear this out. And so far we have x squared plus 4 and x squared minus 4. But the x squared minus 4 can be factored further. So we're gonna go ahead and factor the x squared minus 4 into 2 binomials. Anybody know what the 2 binomials are?
X plus 2 and x minus 2.
Very good. X plus 2 and then x minus 2. There's a plus, and you know what? Let me just make that one minus and I'll make this one a plus. There we go. All right. And so that x squared plus 4, we're just gonna go ahead and bring it down. X squared plus 4. And so this would reflect the complete factored form of this problem. This is completely factored, guys. Any questions? That one was a tough one. It required you to factor it 2 times. So just be careful. All right. Now, let me give you one that's a little bit more challenging. This is going to be number 4. And for this one, I am going to do 25 minus 1/4. Ooh, there's a fraction in there. X squared. 25 minus 1/4 x squared. Now, how do we know this one is a difference of squares? Well, you got your minus sign in the middle. You've got your 25. Can we take the square root of 25 and get a whole number for it? Yes. Now, can we take the square root of 1/4 and get an exact value for it? Absolutely. So yes, this one is a difference of squares. So we're going to set up our 2 parentheses. One is a sum and one is a difference. Now we're going to take the square root of the 25. Square root of 25 is 5. So 5 goes into each parentheses. By the way, guys, when you're factoring these differences of squares, keep them in the same sequence. Don't change the sequence around, all right? Now, next part of this, we're going to take the square root of 1/4. Anybody know what the square root of 1/4 is? That was on the last test.
1/2.
1/2. Very good. So don't forget the x, guys. You must include the x as well. So when we take the square root of 1/4, we get 1/2. And of course, the x squared splits up into x times x. So this would reflect the factored form of this problem. Any questions? All right, so if you guys don't have any questions, I'm gonna move on to the next type, special type of factoring. Anybody? Okay, how about you guys give me a thumbs up if you're okay with this one? All right. Ooh, James, I see that thumbs up, man. That's awesome. You okay, Ashley? Angelica, are you okay there? Asha, you good? Austin, I haven't heard from you. How you doing? Mr. Bragato, are you okay? Awesome. Okay, guys. So now let me go ahead and go to the second type of problems and this special type. And those are the perfect square trinomials. Now, for the perfect square trinomials, I am not going to emphasize them that much because we've already seen the trinomials. We've seen the easy trinomials. We've seen the hard trinomials. So the bottom line is this, guys. I am going to show you a couple of perfect square trinomials, and then, of course, you will notice it's the same thing as before, so you don't have to worry too much about it, okay? Now, I'm writing the wrong thing here. Let me go ahead and erase this part right here. So there are two types of perfect square trinomials. Now, for the perfect square trinomials, we have ones where you have x squared minus bx plus c. And you have the ones where you have x squared plus bx plus c. Now, in order for it to be, oh, I left out my a. In order for it to be a perfect square trinomial, the a value and the c value must be a perfect square. In other words, when you take their square root, you get an exact value. Now, guys, this, you don't have to remember it, okay? You don't have to remember it. I'm just going to show it to you once. If you don't remember it, that's okay. There's other ways to factor this. When you factor the perfect square trinomials, they always turn out to be a binomial square. So for the first one, because this one is a minus, it's going to turn out to be, you know what? Let me just go ahead and do this. Hold up a second. Let me erase this part. Let me just go ahead and show you guys an example so I'm not confusing you with all these letters in here, okay? So let me go ahead and show you one right off. X squared plus 8x plus 16. This, okay, right here, we're going to call it a perfect square trinomial. How do we know it's a perfect square trinomial? The 16, that's a perfect square. The x squared is also a perfect square. Now, if we were to go ahead and take the square root of 16, that would give us positive 4. And if you take positive 4, you multiply it by 2, that would give you positive 8. That's how you check to see if it's a perfect square trinomial. Now, here's why I'm not emphasizing these that much. This is very similar to what we did earlier, where we factored the x squared into x times x. And then we find two numbers that multiply to give us 16. And when we add them, we get 8. And those two numbers would be positive 4 and positive 4. Now, here's why this is a special type. What do you notice about these two binomials, guys? They're the same. They're identical to each other. So we can take this and rewrite it as a binomial square. So essentially, when you factor a perfect square trinomial, it factors into a binomial square. So any trinomial that factors into a binomial square is referred to as a perfect square trinomial. Let me show you another one. Let's say I have x squared minus, let me see here. Let's see, minus 12x, okay, plus 36. Now, this one right here, again, I'm going to do a quick check to see if this is a perfect square trinomial. How do I do my quick check? Can I take the square root of 36 and get a perfect value for it? Yes, I can take the square root of 36 and get an exact value for it. Can I split up x squared evenly? Yes, I can. And so if I were to take the square root of 36, it would give me 6. And if I multiply this by 2, Is it going to give me the middle term? Yes, it does. So then, yes, this is a perfect square trinomial. So when I factor this, it is going to lead to a binomial square. Now, to get to the binomial square, guys, there's a special pattern for it. But once again, I'm not going to show you all of that because I don't want to confuse you, okay? So here's the bottom line. You factor x squared into x times x. Find two numbers that multiply to give you 36, which is the same thing as taking the square root of 36. Add to give you 12. The square root of 36 is 6. So each parentheses will get a 6. Now, because the middle term is negative, that means each factor must be a negative. And just like with the previous problem, you will notice the factors, they're identical to each other. So you can rewrite this as a binomial square, okay? I wanted to keep this simple. Why? Because we've already factored trinomials. So I don't want to emphasize these perfect square trinomials too much, because this is the same thing as what we did earlier with factoring the easy trinomials and factoring by group. I'm factoring by the AC method. So this is the same thing from earlier, guys. So I am going to leave this alone. I just wanted to show you what the perfect square trinomials look like and what the outcome turns out to be. Any questions? Okay, because I got to get to one more thing and then we'll be done with the session. You guys have been doing really well. Thank you so much for hanging in there. I know it's tough. By the way, I didn't ask these questions. How are you guys doing? Is everybody okay? Everybody's well? Okay, I see some thumbs up. Okay, good. Is everybody well? All right. I'm glad you guys are good. Guys, please wash your hands and stay in unless you're an essential employee and you have to go to work, or you have one of those businesses that requires you to be at work. Just taking it day by day. Health wish for your good. Okay. All right. So I'm doing okay. I'm staying home. I've been home since March 13th. Pretty much I don't leave the house. My immune system is in a very compromised state. So I stay put at the house, guys. I don't go anywhere. I'm hoping this thing will pass over soon, but I don't think it's going to be over before the end of the term. And the end of the term is going to happen for you guys on April 27th, okay? So we'll just have to hang in there and try to finish this class, all right? I don't know. Personally, for you guys, if I were in your shoes, I would count my blessings because I get to do all of this in the comfort of my home. I know it's difficult with the teaching process and everything. It's going to take some getting used to. But at the same time, guys, there's so much more you can do at home in the comfort of your home that you can't do anymore. If anything, take that as a positive. How about that? No, I'm talking too much. Okay, so let me finish out. So you missed school. You know, the funny thing is I have people who don't want to be in the classroom when school is in session, when we're doing the face-to-face interactions. And yet, once it's been taken away, they want to be back in school. I don't know about that. That's weird. Well, all I can say is this, guys. The goal here is to keep as many people well, healthy as possible. So we have to do our parts and just stay home, you know, wash our hands and blah, 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 and all that bunch of stuff. So hopefully we'll get out of this and be okay on the other side. Yeah. All right, so let me go ahead and finish this out, guys. Here's the last tidbit, and this is still under the special types. I just noticed it's 8:27 already. I won't linger on this. I will make it quick. Give me about 5 minutes, maybe 10. I'll try not to do 10, okay? So the third part are the sum and difference of cubes, guys. N, that's an N symbol there, okay? N, difference of cubes. And this is something else. I'm not going to emphasize that much because those of you moving on to college algebra, you're probably not going to be factoring these. So you're going to be factoring these type of binomials, the sum and difference of cubes, guys. Now, there is a pattern for this, and you got to try your best to memorize the pattern. So I'm going to start with the sum of cube. When you're factoring a sum of cube, a cubed plus b cubed, you're going to factor this into a binomial meaning two terms, and a trinomial meaning three terms. So when you factor a sum of cube or a difference of cube, you're going to end up with a binomial factor and a trinomial factor, okay? So I'm going to give you the pattern, and I'm going to do two examples with you guys, and then I'll be done. All right, so here it is, guys. A cube is made up of A times A times A. B cube is made up of B times B times B. So to create the binomial factor, we're going to take a factor from each term. So we're going to take an A, we're going to take a B. So the binomial factor for the sum of the two cubes will be A plus B. By the way, the difference between A cubed plus B cubed and A cubed minus B cubed is just a subtraction sign. So since you have an addition here and a subtraction here, when we factor the difference of cube, the binomial is essentially the same thing, but the sign is going to be a negative. That's how you create the binomial factors. All right. So now, since we took a factor from the A cube and we took a factor from the B cube, we've eliminated them. And what do we have left over? Well, we have, here it is, A squared, A times A left over. And A times A is A squared. Same thing is going to happen with the differences of cubes. And then we also have B times B left over. And B times B is B squared, guys. That's going to be the third term. Notice I'm leaving some space in between the A squared and B squared. That is because we're going to have to write something in the middle. So here's the tricky part. To get the middle term, guys, the middle term, the easiest way to do it is to multiply these two together and change the sign. Multiply them together and change the sign. And there you go. So multiply these two together and change the sign. Multiply them together, change the sign, okay? So what do you notice? The negative becomes a positive right there. And then the positive becomes a negative over here. So you gotta remember, the sign must be the opposite, guys. Change the sign to its opposites. That's the pattern for factoring a sum or difference of cube. So now I'm going to do a couple of examples with you guys, and then we'll call it a night. So guys, here's the first example I'm doing with you. It is x cubed plus 27. All right, we're gonna factor this into a binomial factor and a trinomial factor. So here we go. X cubed is x times x times x. 27 is 3 times 3 times 3. To build the binomial factor, to come up with our binomial factor, we're going to go ahead and take a factor from each term. So we're going to take an x from here, okay, and a 3 from here. So the binomial factor will be x plus 3. Notice we're carrying over the same sign. from the original problem. Now, since we've used the x and we've used the 3, okay, we cancel them out. What we have left over is x times x, which becomes x squared in the trinomial factor. And then the 3 times 3 becomes 9. Now, here's the tricky part, guys. The tricky part is the middle term here. So for the middle term, we're going to multiply these two together, the x and the 3. We get 3x. And you got to remember, change the sign. You got to do the opposite sign. Do the opposite sign. Opposite sign. There you go, guys. This is your factor right there. Okay, that's your factors. So when you factor a sum or difference a cube, you will always end up with a binomial factor and a trinomial factor. Now I promised 2 examples and I would let you go. So here comes the second one. I am going to erase this and we're going to do the second one. All right, guys, so here's the second one. It is x cubed minus, let's do 64. Now, for this one right here, remember it's a binomial and a trinomial factor. X cubed is x times x times x. 64 is 4 times 4 times 4. Okay? So now we're going to go ahead and create the binomial factor, guys. What's the binomial factor? What do you guys think?
X minus 4.
X minus 4. Very good. Okay, so on this one right here, guys, you are simply taking an x from the first term, taking a 4 from the second term to create your binomial factor. And so once you've used the x and you use the 4 to create your binomial factor, what do you have left over? What will be the first term, guys? What's the first term?
X squared.
X squared, very good. You're just going to multiply, that's an x right there, guys, okay? You're multiplying x times x. And then what would be the last term here?
16.
16, and you're essentially multiplying 4 times 4, which gives you 16. All right. And now, here's the hard part. What should the middle term be?
4x.
4x. Is it positive or is it negative?
Positive.
It's going to be a positive. Why? Because you multiply these two together, and then you want to change the sign right there to its opposite. All right? So guys, that's it for factoring the difference and sum of cubes. When you factor them, you end up with a binomial factor and a trinomial factor. So you guys have any questions for me? All right. Thank you so much for being patient. Thank you for attending, guys. And I'm going to end the recording right here.